Hello, in this Three.js video, we're going to look at lighting. We're going to look at ambient lights, point lights, directional lights, and spotlights, and how to use them and how they affect materials in your world. So let's just have a look at our world so far at the moment. So if we have a look at this green face with the Cocos Helper logo, no matter where we look at it from or where we look at it, all the colors are uniform if they've been created uniform in the original image, which the green in this example has. Same with the yellow, the purple, the grey, the white, etc. But obviously lighting allows you to create more of an illusion of depth. It allows you to create shadows, and so forth. So let's just show you an image we found right here. So here's a difference between some of the different lights. So you got an ambient light which doesn't have a particular origin. It's a uniform lighting technique which just applies light to all the objects regardless of where they are. They could be really far or they could be really near to the camera. So if you were to apply a white light or a white ambient light with, let's say, an intensity of 5, it would affect every single object by an intensity of 5 using white light. So this is a great general light to have in your scene. So it provides some illumination. Directional light, as you can see by the diagram, it is light that emits from one particular direction, aka towards one particular way. So it has a direction. Point light, it has an origin, then it just emits light in every single direction. This is just suggesting it's like only in 2D, but it's in 3D as well. It's just because the image is 2D, but it emits in every single direction. Spotlight, as you can see, it is like a cone, or if you think of like a stage production when they have lights, camera, action, when they shine a light on the stage to showcase something and everything else goes dark, that's what a spotlight is. Pretty much no scene or no game and no 3D rendering will use one light only. They'll use most likely a mixture of all 4 lighting techniques, because that way it provides you with, okay, I'll give you an example. You might use the ambient light to provide a bit of natural light. So let's say if it's not completely dark, if there's light coming in from outside, but you haven't got a light source out there, so it's just, you would use an ambient light. You could use a spotlight for something like a lamp. You could use a spotlight more for, let's say, a bulb or something that emits light from one particular direction. Directional light could be light from the sun, for example, so forth, so forth. I think you get the picture. So let's actually start implementing it. We're going to start off with the simple light of ambient. So if we go here, we're just going to put it after the camera position, but you can put it really anywhere. So we're going to do var ambient light equals new 3.ambient light, and this takes 2 parameters. The first is a hex, aka the lighting color. We're going to do 0xFFFFFF, which is white, and next it takes a intensity value. I'll put 5.0, save that, go back, refresh. Let's have a look at our object. You might be thinking, I can't see a difference. You might keep looking at it and trying to think, what's changed? And you're right, nothing has changed. And the reason is because of the material that we applied. We applied a mesh basic material which isn't affected by lighting, but on the bright side, no pun intended, but on the bright side, you don't actually need lighting in your scene to view the material, because otherwise, if there's no lighting in the real world or even in the 3D, I mean in a digital world, you still need some sort of lighting to be able to see an object. If there isn't, you shouldn't be able to see anything. Whereas with mesh basic material, you don't need lighting to see it, but likewise, it doesn't get affected by lighting. So you have to change the material to either Lambert or Phong material, just built in to Three.js. Here's the difference between some of the materials. So we got Phong, we got Lambert. Lambert, the way I like to think of it, is it's more of like a matte sort of finish. Phong has a bit more of a shine to it, same with Blinn. So you can think of it like the Phong might be that sort of shine you get on a snooker ball, but most likely you should be able to see the difference. So as you can see, there's a little shine there, and this is more of just like a uniform texture, a matte texture that looks more glossy and shiny. So if we go back, we can just rename these to, let's say, Mesh Lambert. Show you the different Mesh Lambert, Mesh Fong. And I recommend that you just mess around with this, change them to Lambert, to Fong, and just see what the differences are, especially with the different light techniques. So Fong, Lambert, Fong. Save that. So if we go back to our scene, refresh. Ooh. Can't see anything, so let's have a look at the console. You're on the right file, so let's just open up the console just in case there's some errors. Ooh, I spelled Lambert incorrectly there. I put Lambert. It's like we're betting on some lamb. Okay, still nothing. Let's go back. These are just general errors that would have appeared before. So if we refresh, go back. Ah, my bad. I forgot to actually add the lighting. See, I made a mistake, but it was a good mistake to actually illustrate what's happening. Now that we've changed them to Lambert and Fong, because there's no lighting in our scene, we can't view them. So if I were to, let's just say, change just the one side to basic, mesh basic material, refresh. That is weird. So let's just change this back, turn this one to basic as well. Oh, there we go. I wasn't rotating it. Here we go. So we have our side. So we can see certain sides, aka the two that we've enabled as basic and basic. Actually, you know what I'm going to do? I'm going to leave both of them as basic. Leave two as Fong, two as Lambert. So it'll be a great way to illustrate the difference. So now we're going to actually add our light. So what we are going to do is scene.add ambient light. And now what I just remembered is, actually no, I remember that because we didn't add the light, it wouldn't have affected anything anyway, even with the basic. But we know that the green side and the white side is added using the basic material, so we'll be able to have a look at them and see whether or not they're correctly loaded. So if we refresh, as you can see, the white side and the green side are not affected, whereas look at the yellow side, this side, and the Sonar game side, they are heavily white. They've been affected immensely. If I were to tone down the intensity, refresh, that intensity, that's not very intense at all. So let's bump it up to like 3, refresh. As you can see, there's still a high intensity. We can see a bit more of our texture. Let's change this to 2. See a bit more of it. Let's change it to something like 1.5. So we can actually we can see the background of each of our textures now. But as you can see, the white side and the green side is not affected at all because they're basic materials. They're not affected by light, which is fantastic. What I've got in this text data, I created a floor, ceiling, left wall and right wall just using basic geometry and basic texture loading. This will be a great way of seeing how light bounces around in our scene. So we're just going to add this light. So I've already added these textures to our image folder. Again, this is stuff that we've already covered in this series. It will just help illustrate our lighting techniques. So if we go back, refresh, so let's zoom out. So there we go. We have our cube in the middle, and around it we have some walls, we have a ceiling, and we have a floor. But if I were to go back, scroll down, just comment out this lighting, go back, refresh, nothing appears apart from these two surfaces. And again, the reason for that is because we have no lighting. So just to illustrate, I'm mentioning this several times, but it's just going to help bring it home and so you remember it. If you have no lighting and your material is not a mesh basic material, you won't be able to see it. It's as simple as that. Mesh basic, you can see without lighting, but likewise, it's not affected by lighting as well. So just something to bear in mind. And what I'm going to do is, let's say if I were to tone this down to like 0.8, as you can see, everything just looks darker now. But again, this is just ambient lighting. So even though this wall, let's actually move a bit. Even though this wall is pretty big, it affects this part the same way as it does this part, and the same way as it does, let's say, this part right here. It's all affected the same, including what is on the bottom. So let's just refresh this, and I can easily change this to, let's say, a red color, 0000, save that, go back, refresh. We have a red light now. It doesn't look very nice, so let's just switch back to white. So we've covered ambient lighting. Now let's look at point lights. So what we're going to do, remember, point lighting is a light in the scene that just emits light in every single direction. Point light can have an origin, or does by default have an origin, but we're not going to actually set a particular position ourselves. But you can easily do that using position.x, position.y, position.z. You can do all of that good stuff. So do var light 1 equals new free dot point light. First value is the color, which is a hex, so 0x. I'm going to put 0x ff 0040, just some random light values. Next value is the intensity. I'm going to put 4, and the final value is the distance that you want the light to apply. So beyond this distance, no objects will get affected by this light. So I'm going to put 50, and I'm going to put scene.add light 1. I'm going to copy and paste this. I'm going to add total of 3 lights. 2, and for this color I'm going to do 0040 ff, change this to a 3, I'll leave this as a 4, and for this color I'm going to put 80 ff 80, save that. So let's go back, refresh. There we go, we got a bunch of different lights. They're quite bright at the moment, so what we're going to do is actually tone them down a bit. Let's tone this down to 1.5, so we're just halving it all by 1. Refresh. I'm going to tone them down even more. Tone this down to 1. Now I'm going to tone this down to like 1.2, 1.1, and 1.05. Save, refresh. But what I'm going to do, because they're all in the same position, is make them move around using the update method. So they're constantly moving around. So you can actually see the effect of lighting in real time. So what we're going to do is var time equals date dot now. So we're getting the date times by 0.0005. This is just some code that we're going to use to rotate it. This is some arbitrary code. Light 1 dot position dot x equals math dot sign, and in here we're going to put time by 0.7, time by 30. I'm going to copy and paste this. I'm going to change the x to a Y and a Z. I'm going to change the sign to cos, so cosine. Change this one to cosine as well. Change this to 0.5, 0.3, and just multiply this by 40. I've already calculated all of this beforehand, so you don't need to worry about this. I'm just going to change this to 2, to 2, to 2, to 2, 3, 3. Oh, I forgot to modify this. I realized when the IntelliSense wasn't picking light 3 up down here. This is going to be a cosine. This is going to be sine. This is going to be sine. This is going to be sine. And now let's start updating these values. I'm going to put 0.3, 0.7, and down here we're just going to switch these around. And now we're actually ready to run. So let's just run this and marvel in what we have. As you can see, certain aspects of the world, aka certain parts, certain objects are changing lighting because we have lights that are moving around. But what I'm going to do is turn up the intensity again, because that will help illustrate it better. So if I just turn up the intensity, 424, refresh. So as you can see, we've got some lighting at the top. It's quite intense, and now that's going to the bottom part. As you can see, the lights are now changing. This isn't the end of this video, but as an extra task, what we want you to do, because at the moment, you can see the effect of the light, but you don't know exactly where the light is. We want you to create, like, I don't know, another cube or a sphere using the geometry method in Three.js, and just move them with the light. So they'll be positioned where the light is, and they'll move with that particular light. So basically you're attaching an object to a light, so it just looks like the light is coming from a particular object. And you could even use a mesh basic material and assign the same color that you've used as the light color. That would be fantastic, because it'll look like the lights are moving around and you'll be able to visualize them. So we've just covered some point lighting. Let's cover some directional lighting. We'll just leave all this lighting in there, but we will just comment it out. Sorry, not that one. We'll just comment out all the lighting. And directional lighting just comes from one particular direction. And now we're going to do var directional light equals new free dot directional light, and for this I'm going to put 0x so it's going to be a white light with an intensity of 1. I'm going to put directional light dot position dot set. So this is another way to set the position of an object. You do position dot set, and this takes the x, y, and z values. I'm going to put 0, 1, and 0. So if we save that, forgot to add it, so scene.add directional light, go back, refresh. If we rotate it, we have a light source which is somewhere around about here. The light is being emitted from here down there, so this face is visible, as is this face, that, zoom in, that face, but none of these are visible because the light isn't actually touching those particular faces. So that's directional lighting. Let's just comment that out. And now the final light is spotlight. Remember, this is like having a cone, like if you're on a stage and they shine a particular light on the stage and everything else goes dark. It's very similar to that. So what we're going to do is var spotlight equals new free dot spotlight. Have you seen the film Spotlight? Pretty decent. It's okay. Could have been better, but it's okay. before I just talk about that, 0x, FF, 45, these are just arbitrary values I'm putting in. You can do whatever you want. I'm going to put intensity of 25, so very intense. Spotlight dot position dot set 0, 3, 0. Finally, scene dot add spotlight, save, refresh, and that is very, very intense. So if we go back, we've set here to 0, 3, 0. So the only value that isn't 0 that has changed from the initial position is the Y value. So it is somewhere like up here, like so, and it's emitting a cone downwards. So no light touching the bottom and no light is touching the top. So that's it for lighting. Let's re-enable all our lighting, see what it looks like, see how horrible it looks. So this is our lighting as a whole. Like I said, you want to use a mixture of lighting as an extra task. Experiment with the lighting techniques, experiment with the materials, and also try and attach some sort of physical object, some sort of cube, for example, to each light that is moving, or each light in general that has a position, aka everything bar the ambient light, so you can actually see where it's coming from. That would be fantastic. If you have any questions, feel free to post them on our education platform, sonarlearning.co.uk/questions.php, or you can reach out to us in any other manner, social networking, direct message, commenting, however you feel. There'll be a link in the description to our GitHub page where you can get the source code from this video and every other video in this series. And as usual, thank you for watching, and I hope you have a great day coding.